Let's talk about this, right? So physically, how does a compressing piston heat up gas? This is pretty simple, right? When it's compressing, the piston's moving downward, and so a particle of gas, when it bounces off the thing moving downward, comes off with a greater velocity. This is faster. And greater velocity is just simply more kinetic energy, therefore a higher temperature. Okay, so literally it physically speeds up. It's like a ping pong ball, right? You know, it physically speeds up the molecules. Speeds up the molecules. All right. So why does an adiabatic compression that cuts the volume in half more than double? So first off, if it's not adiabatic, if it's isothermal, you would expect that if you cut the volume in half, you would double the pressure. This is just the combined gas law, right? But an adiabatic compression would raises the temperature. And so when you raise the temperature, you now have a hotter temperature and you've cut the volume in half. Therefore, you would get even more than doubling the pressure, right? And then let's see, physically, how does an expanding piston cool a gas, right? Well, physically, the piston's moving up. So now when a particle bounces off of it, it comes off with a lower speed. It's going slower. So it's a bit like in soccer, when you want to trap a ball, it comes at you fast. What you do is you move your foot in the direction that the ball's going, and that's how you trap it. Or at least I've been told that, you know. I'm not the greatest at soccer, you know. But yeah, that's the idea. Is it physically slows the gas, right? So why does an adiabatic expansion that doubles the volume cut the pressure by more than a half, right? Well, when you double the volume, if the temperature stays the same, the pressure should be exactly half, right? You've got twice as much area you've got twice the distance in one dimension for the gas to cross. So therefore, you're having half the collisions. Therefore, you should get half the pressure. But the adiabatic expansion cools the gas. So now you have both doubling the volume and a lower temperature. It's not going to be half the temperature. It's just going to be a lower temperature. And that causes it to be less than half of the original pressure. Okay? I don't know if that makes sense. We can talk about that in class. But this is fundamental, right? So the adiabatic expansion is how refrigerators and heat pumps make cold. And adiabatic compression is how heat pumps and refrigerators make warm. How's that?